This is a branded podcast from Latitude Studios.
Was there any particular moment when you woke up to the power of artificial intelligence?
It's a gradual process. I remember reading a book about Alan Turing when I was a kid, and frankly, not understanding a lot of it, but getting some sort of vertigo from thinking that maybe one day machines could be as sophisticated as our own brains.
That's Laurent Boinot, a power and utilities leader at Microsoft, talking with Stephen Lacey. Laurent spends a lot of time thinking about how AI can help utilities run the grid cleaner and more reliably.
It's a really healthy balance between understanding technology, understanding business problems, and bringing in a vision for where technology is going with AI. I mean, it's a fascinating role at the intersection of all this.
Laurent studied philosophy. He was once a chartered accountant, but he's always had a fascination with artificial intelligence. And in 2010, he took a class at Stanford to learn the back end of AI systems.
I was amazed by how powerful those logic systems were. And I had done logic as a philosophy student. And just it's incredible how computer science takes those basic math/philosophy principles and makes them useful for humanity.
Years later, as a Harvard student cross-registered at MIT, he used a simple AI model to assess environmental and social risk of projects funded by the World Bank. The results surprised him.
And we looked at the grades that were given by human risk experts, I would say. And then we compared that to actual outcome of the projects. Again, with a very basic AI tool, we were able to replicate that risk analysis and do a better job than the human graders did.
Laurent learned 3 lessons about how to make effective use of AI. Lessons he now applies to the power sector.
One is that AI doesn't have to be hugely complex to be very powerful. The second thing is that for any AI system to be powerful and have impact, even before you start thinking about the algorithm itself, it needs great data. And then the third thing as well is that there is, for any AI project to be useful and add value, it needs to be integrated into a workflow.
You're working on a lot of specific use cases with AI adoption inside utilities, in partnership with utilities. How would you characterize the way utilities are treating these tools today?
So utilities show some resistance. Often one of the difficulties we have is that our customers want to be fast followers. And in order to be fast followers, you need to follow someone. So someone has to go first. That's definitely an issue in this sector in particular. But in terms of what can be achieved, it's going to be around integrating renewables. You're going to have examples around grid modernization. It's going to be around enhancing the customer experience as well, operational innovation, security and compliance. All the use cases are going to be around sustainability, affordability, and reliability. And that covers everything.
There are dozens of compelling applications for AI on the grid, but utilities are still in the early stages of adoption. In this episode, produced in partnership with Microsoft, Laurent Boinot talks with Stephen Lacey about where AI can have the biggest impact. They discuss utility adoption trends, barriers to widespread deployment, and why some of the simplest use cases can be the most powerful.
You just listed off so many applications for AI. There are dozens and dozens of applications. Some of them are really cutting edge in terms of fault detection and distributed energy management. But some of the most powerful ones can be fairly basic or maybe not as exciting, one of which is like using AI in the regulatory process.
Thanks for flagging this because, yes, there's a lot of non-exciting things that are really, really key. One of the biggest issues right now for the grid around the world is interconnection. Another big topic is how do you get fast approvals for new projects? And with that in mind, yes, we have a generative AI for permitting solution, which customers can deploy on their Azure subscription, which allows teams to work together on permitting. And permitting, if you take nuclear, for instance, let's take one example. The tool also works for renewables, but nuclears, the permitting can run into the tens of millions of dollars yearly permitting in nuclear is not only for building, for decommissioning, but it's also operationally for bringing new fuel, for the transport of spent fuel, and for other operational aspects of the plant. Really big teams producing documents every step of the way. With a GenAI tool that has ingested all those documents and all the regulations, you can have not only very strong first drafts of the regulation, but you also have the ability to query existing documents to figure out very quickly if what you're looking for is in the document, and in a collaborative way make sense of the massive documents that a power plant would send to get approval for anything it does.
So beyond regulatory applications, where are some other promising use cases in core areas inside the utility? What's getting the most traction?
So we see Copilot, so M365 Copilot, for instance, which is the GenAI layer within the Office suite. We see that being used across the board, both for office type work, but also for field workers. The field workers have with them, for example, a phone or a tablet that will guide them to achieve what they need to achieve with a Copilot layer. So you can interact with your phone or even with AR glasses, and while you perform a task, not only make sure that you're performing the task in the way that it's anticipated, but also if anything doesn't go according to plan, you can ask more questions that can alert you to potential dangers. A lot of applications that are quite deep across the board.
I want to move into scientific discovery now, which is really exciting. Microsoft recently demonstrated that AI could screen tens of millions of candidates to discover new battery materials. And I'd like your thoughts on how AI is being used for scientific discovery to accelerate clean energy solutions and then also to help with utility operations and procurement.
Yeah, this is fascinating. So what you're referring to is a project where AI was leveraged by our research teams to screen over 32 million candidates for a new electrolyte for advanced batteries. Thanks to AI inference, the R&D scientists were able to go from that number to then 500,000, and then with fast AI screening and also high performance compute simulation, go to 100. Again, go through a different layer of screening, including high performance compute of molecular dynamics, so really simulating the actual molecular behavior with the latest few, 18 to the 1, with expert-guided AI models and human-informed validation. So the ability to discover new compounds is really powerful, not only because it allows for potential new material, better batteries, which would go a long way to make the grids more stable and integrate distributed energy resources. But also, if you think about the big power plants, some of the output of a nuclear power plants can be leveraged and the output is being used today for cancer treatment. Those isotopes are treated by medical companies and then used in radiation therapy. And you can imagine having high-performance compute simulation as well there to potentially find new usage or find different isotopes. The material science aspect of this is really interesting.
Absolutely. And you can see that will directly influence companies that are developing new technologies, but bringing it over to the utility, how can these high-performance simulations maybe help utilities evaluate new technologies? Are there ways that they can integrate some of this into their own thinking about the energy transition?
I'll mention too, Hydro-Quebec, for instance, as a whole menagerie of robots for inspecting power lines, for inspecting the actual line, but also for inspecting vegetation around power lines, preventing fires. All that, again, very boring kind of maintenance type conversation, but they have a really, really big impact when things go wrong. And so all those robots, there are a lot of AI in the background to code those robots, to interact with those robots. Another customer where we have a tight partnership is Constellation. And with Constellation, we have a project called 24/7 7 matching, which is actually not a project, it's a product. And with that, Constellation is able to tag its green electricity hourly, which means that when you buy green electricity from Constellation, you're not buying net, you're actually buying actual green electron. So the difference is the electron you're using is green. And so that's very powerful as well to go from net zero to actual zero emission.
So anyone who has worked with utilities or watched the utility industry really understands that it's a very conservative industry for obvious reasons, security reasons. They're operating critical infrastructure, which is often under threat. They're really focused on reliability. What would you say are the biggest technical or organizational hurdles that you're facing when exploring these tools in partnership with utilities?
So some of the hurdles are regulation or the perceptions of regulation. So for instance, if you think about NERC CIP, which is the North American Electric Reliability Corporation's Critical Infrastructure Protection Standard, there is a perception that what NERC CIP does is prevent you from doing anything in the cloud. It's not the case at all, and our customers get it. But initially, there is this perception. You can think of it as traveling to an airport. In the past, you used to jump on an airplane, and now you go through TSA. If the TSA goes from 30 minutes to 3 days, nobody travels anymore, right? You need to find a balance between security and unlocking all the opportunity, allowing you to actually manage the grid properly. And actually, AI has been used by a customer like Uniper, which is one of the leading multinational energy company based in Germany. And they use a tool called Security Copilot. And what that specific Copilot does, it goes from flashing red lights on your screen, where as a human, you have to understand what the red light means, to actually telling you in a natural way that actually, those two things that are flashing are connected. It's 2 doors in the same corridor that are not closed properly, and therefore there's a risk of intrusion. Security Copilot can also allow you to make sense of your IoT devices connected with Defender for IoT. So again, with the complexity of securing those really constantly targeted customers, like the electricity providers, having the ability to automate some of the day-to-day grind of reports, of alerts, makes a really, really big difference and empowers the human to do a lot more.
Where would you say we are on the adoption curve?
So it's a tough question to answer for 2 reasons. One, because customers are different steps. And also because when you say adoption curve, you mean getting to somewhere, and that somewhere is constantly moving. But if I think about, generative AI for office workers, typically, there's a lot more that can be achieved, for sure. We see in some cases very significant efficiency gain. I have a customer that did a report where they found that after just a few weeks of usage, each employee had or achieved a day more of productivity every week. So that's very significant. And I expect that to be eventually rolled out across the board.
I know you've been thinking a lot about the energy, environmental impacts of AI as well. And there's this ongoing debate, not just in the energy sector, but now in the mainstream, about AI's energy consumption versus its efficiency benefits. And I'm wondering, based on what you see in the field, like these actual deployments and ways that they can help utilities become more efficient, adopt more clean energy, help companies explore new types of materials, how do you evaluate that trade-off with the obvious increase in energy from data centers, but the societal benefits of AI applications?
Yeah, you're right. The data centers use a lot of energy, but you'll have to use a lot of very dirty energy to compensate how much more efficient you can make the process of identifying sites for clean energy. And I'll take one example. We have a partnership with an NGO called TerraPraxis. And with TerraPraxis, we are identifying coal power sites for repowering to nuclear and SMR, so small modular reactors. And that is really powerful because the coal sites are connected to the grid. Otherwise they wouldn't be there. They're already classed as industrial, so there's less of a risk of not in my backyard type behavior. And once those sites are identified with a lot of AI algorithms, then you can leverage the permitting with GenAI as well to make sure you are as efficient as possible in building the plant and getting it online with carbon-free electrons. The other part of that conversation that is really interesting is that if you think about cutting-edge research in AI, there's almost two labs in the same building, if you think about it. One lab where the goal is to do the most impressive thing, those are the cutting-edge models, right? In the other lab, you take the cutting-edge model from 2 weeks ago and you say, okay, now this is the capability. How cheap and how light can this be? So there's almost two curves. There's the cutting edge of AI and what we can unlock with increasingly sophisticated models. But on the other end, there is like how cheap, simple, and light, and eventually sustainable can compute become.
So you've got this unique window into this array of solutions. What do you think is going to surprise people about adoption or capabilities?
One of the things I'm thinking about, for instance, that we haven't talked about is agentic AI, where instead of connecting two separate software solution with APIs or with some sort of convoluted connector, you can have an AI system working across the board to achieve a task across systems. So that's for sure going to get really powerful and really important. But maybe the biggest surprise would be that, even with self-driving cars, even with some of the crazy sci-fi scenario that now we are starting to envisage, maybe the most surprising thing is that there's nothing new under the sun. Humans are still humans. We are still good at what we are good at. And like all other previous massive changes that we've gone throughout history, we'll find a way towards a new normal and a new obvious. We're very good at finding things normal when we grow up with them. So that's what I would expect.
Laurent, thank you so much. I really enjoyed this.
Thank you, Stephen. Thank you for having me. Please reach out on LinkedIn if anybody wants to have an AI, Gen AI, Power Utility conversation. I'd love to hear about other use cases people are working on. Any thoughts people want to share, I'd love that. So thank you.
To learn more about how Microsoft is working with utilities and other energy companies to deploy AI to accelerate the energy transition, go to Microsoft.com/industry/energy.